Okay, imagine this for a second. What if everything we see, every star, every galaxy, what if it all exists inside something we usually think of as, well, a destroyer? Today, we're tackling a really extraordinary cosmic mystery. It's this radical theory, the idea that our whole universe might literally be inside a black hole. And what's wild is that new data, groundbreaking stuff from the James Webb Space Telescope, the JWST, is actually giving this idea some surprising weight. It's pushing us to rethink, well, everything, reality itself, and our place in it.
It's a concept that really challenges what we thought we knew about cosmic origins, doesn't it? So our mission for this deep dive is basically to explore how this audacious idea came about, what evidence actually supports it, and crucially, what are the big challenges it still faces?
Right.
Because this theory comes from a fascinating mix. You've got cosmology, quantum physics, and some really out-of-the-box thinking. People like Nikodym Popowski, for instance, have been proposing that maybe our universe was born inside a black hole, one that exists in a bigger sort of parent universe.
Okay, let's really try and unpack that core idea. So the usual picture is a massive star collapses, right? And it forms this infinitely dense point, a singularity. But this theory says something different happens. How does that connect to our Big Bang?
Exactly. So instead of that infinite singularity, which is frankly where our physics kind of breaks down, the theory suggests the collapsing star actually forms a whole new expanding universe inside. And well, that could be us.
Us, our universe.
That's the proposal. So the Big Bang, 13.8 billion years ago, it wouldn't be the absolute beginning. It might be more like the moment our universe started expanding inside that black hole's interior. A kind of cosmic bounce, maybe?
Wow. That is a profound shift. And you mentioned JWST. Its observations seem to fit with this radical idea, especially from that Sears survey. What exactly did JWST see that makes this black hole universe theory, well, intriguing?
What's really striking, is how JWST is showing galaxies forming shockingly fast. I mean, appearing surprisingly mature within just, say, 200 million years at the Big Bang.
200 million years. That's incredibly early.
It is. We're talking about looking back to redshift 10, or even higher. The universe was basically an infant, finding these big, bright galaxies there. Well, standard models really struggle to explain that kind of rapid growth.
But the black hole model, it handles this better.
It fits surprisingly well, actually. Popowski suggests that the spin and this thing called torsion inside a black hole could provide the conditions, the sort of seeds, for the rapid expansion and structure formation we're observing.
And it's not just the speed, right? JWST has shown us other things, like the universe's overall shape, its geometry.
Absolutely. JWST's infrared capabilities have spotted these massive, bright galaxies in the early universe that just seem, well, too big to develop for their age. Now, in a black hole universe scenario, we've got intense gravity, obviously, but maybe also this quantum torsion effect.
Torsion, like a twisting.
Sort of, yeah, like the fabric of space-time itself has a tiny twist at microscopic levels, and that combination could accelerate galaxy formation. Plus, the universe appears remarkably flat. JWST's precise measurements of the cosmic microwave background confirm this flatness. And interestingly, that aligns perfectly with what theoretical physics predicts for the conditions inside a black hole's event horizon. Space-time there is stretched incredibly flat by the gravity.
Okay, this is sounding surprisingly coherent almost. But I have to ask the big question. Can we actually prove this? What are the major hurdles?
And that's the critical point. It's compelling, but hurdles exist. First off, we can't directly observe any parent universe, can we? By definition, if we're inside a black hole, its event horizon traps us. We can't see out.
Right, so the JWST data is suggestive, maybe circumstantial, but not definitive proof.
Exactly. It doesn't confirm it outright. And then there's the big one, the singularity problem in standard physics. Our current understanding of gravity, Einstein's general relativity, predicts that matter in a black hole collapses to an infinitely dense point, a singularity. Physics breaks down there, and if everything crushes to infinity, there's no room, no mechanism for a new universe to form inside.
So how does this new theory get around that fundamental problem, this singularity?
Well, it has to invoke what you might call exotic physics, specifically a framework called Einstein-Cartan gravity. It's basically an extension of general relativity. It adds this extra property to space-time, this torsion, this twistiness we mentioned.
The torsion again.
Yes. So instead of space-time just curving, it can also twist. And under the extreme conditions inside a collapsing star, this torsion could create a kind of repulsive force. Think of it preventing total collapse. Instead of hitting an infinite singularity, the matter might sort of bounce and start expanding outwards, forming a new universe.
A cosmic bounce powered by space-time twisting.
That's the idea. But it relies on physics that's still theoretical and incredibly hard to test directly. The scales involved are just immense. We're pushing the boundaries here.
So, bringing this back,
Yeah.
what does this all potentially mean for us? For you listening, why should you care if we might be living inside a black hole?
Well, it's not just abstract physics, is it? It fundamentally changes our cosmic address, our whole origin story. If it's true, the Big Bang wasn't necessarily a unique one-off event. It could be just one event in a potentially infinite chain. Universes birthing new universes through black holes.
Like cosmic nesting dolls?
Kind of, yeah. It suggests creation isn't finished, it's an ongoing process. And it connects our existence, however small, to this potentially vast network of parent universes, child universes. It's a profound shift in thinking about reality itself. Opens up some truly mind-bending possibilities.
It certainly does. Really makes you rethink everything. So the question for you to ponder is our reality just one layer in this infinite cosmic onion? Or is this just a fascinating, maybe even beautiful hypothesis? Something to think about next time you look up at the night sky. He really captures the spirit of exploration, doesn't it? Daring ideas meeting the universe's deepest secrets. Thanks for joining us on this deep dive.